Hi and welcome to this week's lesson with TheMathsTutor.ie Leaving Cert Ordinary Level Maths Countdown. This week we're going to be looking at statistics, so we're continuing with our statistics this week with standard deviation and correlation. And every week with these lessons we make a couple of the videos available that are available to all of our full members on the TheMathsTutor.ie website. So we make these available for everyone who's tuning in for these lessons. So the first video this week is how to use the older version of the Casio calculator to find the standard deviation. So just in case you have the older version, there's a video there to show you. I'm going to show you today in this lesson how we use the newer version of it. So you should be able to see that on the screen there. And the second video then is from 2018 paper 2 question 7. So it's a worked example from the papers again to show you some questions on standard deviation and correlation. Okay, so the first thing we're going to look at today then is how to find the standard deviation on the Casio FX83 or 85 GT, and that's the one that has Class Whiz written on it. So if I want to find the standard deviation, I'm first going to have to put my calculator into statistics mode. So to do that, I'm going to press the Shift button and then I'm going to press the menu button. And why I'm doing this is that I'm going to turn on the frequency. So it says here statistics. So I had to press the arrow down to get number 1 to be statistics, and I'm going to turn on the frequency. Now you can turn the frequency on or off, but it's often easiest just to leave on the frequency. And what that means is that if I have a frequency table and want to use my calculator, it's in the right mode. And if I don't have a frequency table, if I just have a list, the frequency is going to be automatically set to 1. So now to use this, I'm going to press menu and I get these options up here along the top. And the second one here has this little histogram symbol. So that means I'm going to use number 2, which is going to be my statistics. And then we've lots of different types of statistics that come up here as options. But what we're going to be using is the first one here where we have one variable, so number 1. And now you can see that frequency column that I turned on is listed here beside my X values. And that would be very handy if you have a frequency table and you want to include your frequencies. I'm working off a list in this example here. So you'll see that my frequencies are just going to be set to 1 automatically when I put in my X values. So now that I have my calculator set up, I'm just going to type in the numbers that are on my list here. And each time I do them, I press 2 and press equals, and you see that it's gone in here as my X was 2 and my frequency is 1. And I just keep doing this and adding in all the things that are on my list into my calculator. Okay, so I've put in all 15 terms that are on my list. So I can see that we've gotten down as far as number 15 and that X value is 30. And for each of them, the frequency has been set at 1. I want the calculator to do the analysis for me. So I want the calculator to work out the standard deviation for me. So I press this button here, OPTN. So this button here. And I see what do I want it to do. So I want it to do these one variable calculations. So I'm going to press number 3 and I get this table showing up here with lots of information. So the first thing I see at the top here is X with the bar on top of it or the line on top of it. And in last week's lesson, we mentioned that this symbol here meant the mean. And we actually calculated the mean of this list of numbers. So we can see here that the mean is 14.6. The one that we're looking for today is going to be the standard deviation. And the symbol that we have for the standard deviation is going to be a sigma. So it's a sigma symbol is what we're looking for. So I see that we have sigma X is the second last one on the list, and that's the one that we're going to want to use. So it says 9.293725482. So I'm going to round that to 2 decimal places, so 9.29. Also on that calculator, if I move down, I can see that there's Q1, which we talked about last week, the lower quartile, and Q3, the upper quartile. And we can also see the median, which we said was the middle value. Now, there's a lot of other things that we don't need. So they've put lots of other things onto this that we're not going to need. But the important ones there are my X bar for my mean, the second last one, my sigma X, the standard deviation. And then when I move down, I can find my interquartile range using Q3 minus Q1 and my median. When I'm finished, if I press the AC button, it brings me back to my table. And if I press the AC button again, my calculator is still in statistics mode. So to tell it I'm finished with statistics mode, we're going to go back to part 1, which is my normal calculations. So hopefully that's helpful to see how we calculate the standard deviation on the newer version of the Casio. And if you have the older version, that video there that we're making available to everyone watching this lesson will show you how to calculate it on the older calculator. So then we're going to look at a couple of questions of where we're going to see our standard deviation in use, and this is going to be tied into something called our empirical rule. So when we're dealing with our empirical rule, we're going to have something that is normally distributed. So this graph here is a good example of something that is normally distributed, and it gives us something called a bell curve or a normal distribution. And what's important about this is that this here, this part in the middle here, is the mean and the median and the mode of all of this information here. And when we're looking at our standard deviation, we're looking at how spread out the data is around this middle here. So we have this symmetrical curve, and we're going to be seeing that we have data being spread out on both sides. So when we're dealing with our empirical rule, we're going to have our median in the middle, or excuse me, our mean in the middle. And then what we're going to be interested in is increasing by 1 standard deviation, by 2 standard deviations, and by 3 standard deviations, and subtracting by 1, by 2, and by 3 standard deviations. And we get it normally distributed, and it remains symmetrical. And there are 3 important percentages that we're going to be interested in. So 68% of the data is always from 1 standard deviation below the mean to 1 standard deviation above the mean. So that means from here where we subtract a standard deviation from our mean to here where we add a standard deviation to our mean. Our next important figure is going to be 95%, and this is where we subtract 2 standard deviations up to where we add 2 standard deviations to the mean. And the last important figure is going to be our 99.7, and 99.7% of our data is from 3 standard deviations below the mean to 3 standard deviations above the mean. So this is where we subtract 3 standard deviations and we add on 3 standard deviations. So that's what our first question that we're going to look at here is going to be talking about our empirical rule. So 2021 paper 2 question 5 part A says the heights of a given population are normally distributed. So that's this bell curve or a normal distribution, and it tells us that 95% of the population, so 95% of the population fall within the height range from 147.9 up to 178.7 centimeters. So it says, using the empirical rule, find the mean and the standard deviation of the distribution of heights in the population. Okay, so we know when we see this 95% here, that's telling us our second figure over there, 95% is from minus 2 standard deviations up to plus 2 standard deviations. So this point here on my bell curve or my normal distribution is minus 2 standard deviations, and this is when we add on 2 standard deviations. So because these are symmetrical, our mean, which we can call x bar or mu, is going to be exactly halfway between them. So that means that we can average these 2 figures, so we can add them together and divide by 2, and that'll give us what's halfway between them. So we're going to say 147.9 plus 178.7, and we're going to divide that by 2 to get what's halfway. And that gives me 163.3, and that's going to be my mean. So I can fill that in here as 163.3 is my mean. Once I've calculated my mean, I now want to work out my standard deviation. So from this point in the middle to either of those numbers that we were given originally is going to be a gap of 2 standard deviations. So if we take the 178.7 and subtract the mean that we have just calculated of 163.3, that's going to give me a figure of 15.4. So that means that 15.4 is 2 standard deviations. So there's 2 standard deviations is 15.4 centimeters. So when we divide by 2, we're going to get our standard deviation is equal to 7.7. So we fill in those values. So our mean is 163.3 and our standard deviation is 7.7 centimeters. So we'll see another question in a few minutes on our empirical rule and our standard deviations as well. But the part B of this question is the other topic that we want to look at in this lesson. And this is looking at our correlation and when we're looking at a relationship between 2 pieces of data. So this is going to be bivariate data. So part B here says the following table shows data on the height and arm span of 20 teenagers. So we can see that there's 12 females and this is their height in centimeters and this is their arm span in centimeters. So we've taken 2 pieces of data for each of these people. So this is going to be bivariate data. And then this is the data for the males. So we can see that these males here, we have their height in centimeters and their arm span in centimeters. So again, it's bivariate data. So it says complete the scatter plot below by adding in the data for the males, the data in the shaded section of the table. So I've already started filling in some of this data. So we can see 168, 169. Now, this is a data or a graph of height versus arm span. So we see that they have put height here along the x-axis and arm span along the y-axis, and they've put in the units for both in centimeters. So they had filled in all the details for the females and we've been asked to fill in for the males 168, 169. So I've gone across to 168 on the x-axis and up to 169 on the y-axis and I've drawn in this blue dot. I've done the same across to 147 and up to 150 and drawn in the dot, across to 134 and just barely moving up to get 121, and across to 177 and up to 176, and the last one across to 172 and up to 170. So I have this one filled in as well. So I have 3 dots left to fill in. So the next one says 160, 163. So I'm going to come across to 160 and then I'm going to go up to 163. So that's just above this 160 and we're going to put in a dot. So 160, 163 will be about here. And the next one, so I'll just tick that I've put that in, 152, 151. So I'm going to come across to 152. Now remember, each of these boxes is 5. So you're dividing it into 5 pieces. So there's 151, 152, and I'm going up to 151, and that data is going to be here. And the last piece is going to be 153 and 151. So we go across to 153 and back up to 151 and we draw in our last dot. So now we've filled in all the data on our correlation table here, or on our scatter plot. And they could ask you to plot all the points and they could ask you to draw your scale. We would normally look at folding away part of this if we're not using all the figures. So you might see this symbol where it just gets folded away because we're not using any of the figures from 0 up to 125. You could be asked to fill them all in. Remember to space it evenly and to make sure that you're labeling your axes. So what do they mean? So now that we've drawn our scatter plot between these 2 pieces of information, it's going to ask us something called the correlation coefficient. So it says one of these numbers here is the correlation coefficient of the data. The correlation coefficient is often given the letter or, and this is where we're going to be looking for a number that it shows the relationship between these 2 pieces of data. And the smallest that or can be is -1. and the largest that it can be is 1. So we can never have any figure bigger than 1 or any figure smaller than -1. If I have a positive correlation, so how do I know if I have a positive correlation? So this correlation is a relationship between the two pieces of data. So here we have the height and the arm span, and I can see that when I look at these points, they seem to be going up overall. So that tells me that here we've got positive correlation. If I have a negative correlation, so they're the ones that are going to have a minus in them, when I would draw these points on my scatter plot, they would come down overall. So we'd have something coming down the way would have a negative correlation. So the graph that we've filled into has a positive correlation because our points are going up the way from left to right. And this sketch here shows a negative correlation because they're coming down the way. So this graph here would have a correlation of a minus number, and the graph that we're working off has a correlation of a positive number. If we have a value of -1 and 1, it means that they make a perfect straight line. So we describe this as perfect positive correlation, and we describe this as perfect negative correlation. Now, neither of these graphs are perfectly in a straight line up or perfectly in a straight line down, but we can see that they are getting close to it. And we describe that as strong correlation. So we have strong correlation when we're looking at figures from approximately 0.6 to 1, we have medium correlation. And again, these are approximately 0.4 to 0.6. And then we have weak correlation from approximately 0.1 to 0.4. And we have no correlation if we have an answer of 0. So if they don't make any semblance of making a line, then we're going to say there's no correlation between them. There's lots of different types of correlation, but for Leaving Cert, all we look at is linear correlation. So we're going to look at how close to making a line they are. So these are approximate numbers that we use for strong, medium, weak, or no correlation. And sometimes we describe this as moderate correlation. So you might have that word rather than medium correlation. And if we have negative, then we just put a minus in front of the figure. So when I look at this graph that we've just filled in our blue points onto, we want to look at what kind of a correlation does it have. Is it 0.2, 0.9, or minus 0.6? So minus 0.6 would be a negative correlation. So that would mean that our points would be coming down the way as we look at it. So we can rule that one out straight away. And then we have a 0.2 and a 0.9. So a 0.2 is weak correlation and a 0.9 is strong correlation. When I look at these points, I can definitely tell that they're going up. So this is going to be a strong correlation. So I'm going to tick the box for 0.9 on this case. So again, we're looking at whether it's strong, moderate, weak, or no correlation. And we're looking at whether it's a positive correlation or a negative correlation, whether it's making the line go up from left to right or down from left to right. And then we want to explain what's happening, or what does this correlation mean. So this correlation coefficient of 0.9 is going to tell us something in general, which is that there is strong positive correlation. But we also want to be specific. So in this case, we're looking at a relationship between height and arm span. So what this tells me is that the bigger we go across here with height, the bigger we tend to go here with arm span. And that's what we're going to write. So we're going to say the bigger the height, the bigger the arm span tends to be. So now I've answered in general what that correlation tells me, whether it's strong positive, moderate positive, weak positive, no correlation, weak negative, moderate negative, or strong negative correlation. And then we're going to say specifically for this question, this tells me that the taller the person is, or the bigger the height is, the bigger the arm span tends to be. And we use this word tends to be, so we don't say that it's definite. That's where we have perfect positive correlation. And the reason for that is I can see this dot here, this person is about 174 centimeters high and has an arm span of 170, whereas this person here is shorter. They're about 169 centimeters tall, but they have a longer arm span. So it's not definite that the bigger you are or the taller you are, the bigger your arm span is going to be, but it is this pattern that's there, that the bigger the height or the taller the person is, the bigger the arm span tends to be. So we put in that word tends to be an awful lot when we're looking at correlations. So then we're going to jump back to our empirical rule for the last part of this question here. So this is 2020, paper 2, question 3, part B. So this says an aptitude test was taken by 6,500 candidates. The test scores were normally distributed. So now we have our normal distribution. The mean score was 480 and the standard deviation was 90. Okay, so our mean, X bar, is equal to 480 and sigma, our standard deviation, is 90. So that's the information that we're picking out from this line here. On the distribution below, the shaded area represents all candidates who were within one standard deviation of the mean. Write down the value of A and the value of B into the boxes below. So this value here in A is going to be our mean minus our standard deviation. So it tells us here that it's one standard deviation. So we're going to be saying our mean is 480 minus our standard deviation of 90, and that's going to give us a figure of 390. So we'll fill that into box A. And box B is going to be our mean plus our standard deviation. So that's going to be 480 plus 90, and that's going to give us a value of 570. So there are values of A and B, and we calculate those just by using our empirical rule. So we know we've one standard deviation above and one standard deviation below. And using that empirical rule, we're going to estimate the number of candidates in this shaded region. So within this shaded region, from -1 standard deviation to +1 standard deviation, we know that's going to be our 68%. So 68%, 95%, and 99.7 are our three important figures. So here we're going to have 68% of the total number of candidates, which was 6,500, and that's going to give us a figure of 4,420. Okay, so that's another example there of using our empirical rule, and this time we had no figures on the bottom of our x-axis except for the mean in the centre. In the last question, we're going to look at 2017 paper 2 question 5. We see that there's one figure filled in, but it's not going to be the mean. So this says in a survey, the IQ scores of 1,200 people, so we're just going to make a note of how many people, the mean score was 100 points. So X bar is equal to 100. The number of people is 1,200 and the standard deviation was 15. So our sigma is equal to 15. And we're going to assume that they're normally distributed. So that means we can use our empirical rule and we'll have our bell curve. And we're going to fill in the numbers on the x-axis here, or on our axis underneath our IQ scores. So we can see that they filled in one for us already. We can see that 85 is filled in. The center one hasn't been filled in. So the center one, remember, is always going to be our mean. And here we're told that our mean is 100. So I'm going to fill in our 100 here. And then each of these boxes, because we're dealing with one standard deviation above, two standard deviations above, and 3 standard deviations above. These are all coming from adding and subtracting our sigma to our x bar, or our standard deviation, with our mean. And that's coming from our empirical rule. So to work out what's going to be in each of them, we're going to say we have 100 as our mean, and we're going to add on 15. So that gives us 115. And then we add on this standard deviation again, which gives us 130. And then we add on the standard deviation one more time, and we get 145. So that's all our positive ones where we're adding on our standard deviation. And then we're going to look at subtracting. So we're going to say 100 minus 15. So that gives us 85. So that's the one that's filled in for us, and we know we're on the right track. And then we're going to take away another 15 from that, and that gives us 70. So we can fill in our 70 on this box. And then we're going to take away another 15 from that. 15. And when we subtract another 15 from that, that gives us 55. So that's how we work out what goes in each of those boxes along the bottom of our normal distribution curve. And then it says a person is chosen at random from those surveyed. So this is from the 1,200 people that were surveyed. Use the empirical rule to find the probability that this person has an IQ score between 70 and 130. Now this time I'm looking for a probability. I'm not looking for the number of people. So 70 is here and 130 is here. So I can see that we're looking at 2 standard deviations below and 2 standard deviations above. And we know that there's 95% of the data is in there. So there's a 95% probability of choosing a person that has an IQ of between 70 and 130. So the probability IQ between 70 and 130 is going to be 95%, or 0.95, or 95 out of 100 if you want to write it as a fraction. And the last part then is use the empirical rule to find the approximate number of people surveyed with an IQ score of between 85 and 115. So 85 is here, 1 standard deviation before it, and 115 is here, which is 1 standard deviation above it. And we know that this is 68% of the data when we're dealing with our empirical rule. So that means we're going to have 68% of the 1,200 people that were surveyed. So we're just going to find 1,200 and multiply it by 68%. And that gives us a figure of 816. So it's just very important to be careful when you're using the empirical rule to answer questions like this. So both of these questions said use the empirical rule. But in one of them we were finding a probability, and in the second one we were finding the number of people. So very important to remember those percentages: 68% from 1 standard deviation minus from below the mean and 1 standard deviation above it. 2 standard deviations below and above is 95%, and 3 standard deviations above and below is 99.7%. And that's how we use our empirical rule. So hopefully that lesson has been of some use to you. And don't forget, we have 2 videos there, one on showing how to find the standard deviation on the older version of the Casio, and one example from the papers. Thanks.